Ever wonder what the real secret sauce is behind something like ChatGPT? Well, today, we're going to pull back the curtain on it. It's a powerful mechanism called attention. And honestly, it's the breakthrough that finally taught AI how to grasp the super complex, tangled web of relationships that connect our words.
Okay, so let's start with a little puzzle. Think about it. Our language is just packed with ambiguity, right? Words' meaning can totally change depending on what's around it. For a computer, well, it's a total nightmare. So how in the world is it supposed to know which meaning to pick?
I mean, just take the word mole. In one sentence, it's a small, furry animal digging up your lawn. In another, it's a specific number of atoms in a chemistry class. For you and me, the context makes it a no-brainer. But for a machine to get that, it needed a completely new way of looking at things. And that answer, that brilliant idea, is called self-attention.
All right, so how does this whole thing actually work? Well, to get a grip on context, the self-attention mechanism basically gives every single word a simple recipe. And this recipe has just 3 key ingredients. This is what lets each word sort of talk to all the other words in the sentence and figure out what really matters.
Okay, ingredient number 1. Each word creates something called a query. You can literally think of this as the word asking a question. It's shouting out to the rest of the sentence, hey, is anyone over there describing me? Or maybe, which verb am I supposed to be linked to?
Second up, each word also makes a key. And this key is like a signpost or label. It's basically advertising what kind of information that word has to offer. So the query from one word goes around and checks out all the keys from the other words, looking for the one that's the best match.
And finally, the third ingredient, every word has a value vector. Now, this is the good stuff. It's the rich, actual meaning of the word. So once a query finds the perfect key to match with, the value is the prize. It's the juicy information that gets handed over to build up that all-important context.
Okay, so we have our 3 ingredients: query, key, and value. But how do they all come together? Well, it's a really elegant 3-step dance that lets the model figure out exactly which words in a sentence it should be paying attention to.
It all starts with a comparison. The model takes every single query and matches it against every single key. That gives it a raw score for how relevant they are to each other. Then, step 2, it does some quick math to turn those scores into percentages. You can think of it like giving each word 100% attention budget that it has to spend on the other words. And finally, and this is the magic part, it creates a brand new context-rich version of each word by mixing together the values from all the other words, using those percentages as the recipe.
Let's make this real. Look at the phrase, a fluffy blue creature. The word creature sends out its query, and bingo, it finds really strong matches with the keys from fluffy and blue. So it spends almost its entire attention budget. We're talking 40% on one and 45% on the other. By doing that, it literally pulls in their value vectors, soaking up their meaning. It's no longer just a creature, it's become a fluffy blue creature.
Okay, that's great for hooking up adjectives with nouns. But let's be real, language is way more complex than that, isn't it? What about all the other types of connections that words can have?
I mean, you've got grammatical stuff, syntax, like how a verb connects to its subject. You've got pronouns pointing back to a person mentioned earlier. And sometimes the connection is just about the general vibe, right? The word wizard showing up nearby completely changes how we think about the name Harry. The problem is, a single attention calculation might get really good at spotting one of these, but completely miss all the others.
So, what's the solution? How can the model juggle all these different relationships at the same time? Well, the answer is just brilliantly simple, and it's really the core of what makes today's AI so darn powerful. You just do it all at once, in parallel. And this is what we call multi-head attention.
So instead of just one set of query, key, and value ingredients, the model has dozens, maybe even hundreds of them. Each one of these is called an attention head, and you can think of them like a team of specialists. You've got one head that's an expert at spotting adjectives and nouns. Another's job is to find verbs and their objects. A third one is a pro at tracking pronouns. And the best part? They all work at the same time, in parallel, each grabbing a different slice of context.
And that right there is why attention was such a game changer. I mean, a total seismic shift. This wasn't just a small improvement on old ideas. No way. This was a brand new foundation for building AI that was way more powerful, totally parallel, and could be scaled up like never before.
You know, the groundbreaking paper from 2017 that introduced all this, it had the perfect title, Attention is All You Need. And at the time, this was a radical idea. It basically threw out the old playbook. It got rid of that slow, one-word-at-a-time processing that older models used. For the first time, a model could look at an entire sentence, all at once.
And that one single innovation, it just kicked off an absolute explosion in AI. Suddenly, being able to process everything in parallel meant we could build models that were bigger and train them faster than anyone thought possible. And that's the direct line. That's the ancestor of all the powerful language models that are everywhere today.
Yeah, that whole parallel processing thing is the key to how AI scaled up so ridiculously fast. It's what unlocked the door to building models with over 1 trillion parameters. Think about that, 1 trillion tiny little knobs the AI can tune, allowing it to store and process just unbelievable amounts of knowledge.
So if there's one thing to really take away from all this, it's this. Attention isn't some fixed set of rules someone programmed in. Not at all. It's a flexible, dynamic system that the model actually learns while it's being trained. It teaches itself how to focus, how to decide what's important, and how to build a deep understanding of language completely from scratch.
And that leaves us with a pretty wild final thought, doesn't it? In the process of building this, we basically created a mathematical model for focus, a system that weighs information to create meaning. So, what could that possibly tell us about how our own minds pull off that exact same magic trick every single second of every day?